Hello everyone. In this video, we are trying to learn about analyzing precipitation, temperature, and Ndvi data in earthengine. These are being adapted from earthengine tutorial training resources, and these are developed by Pietro Ceccato for public health training done by the Columbia University International Research Institute for Climate and Society. The actual training is best for the diseases, but here we are trying to learn about the data and codes. And this video in particular is less about codes, but more about exploration of the data. And we later see that the same codes being used for all the three data. To start with precipitation data, we have this TRIPS data, which stands for Climate Hazards Group Infrared Precipitation with Station Data. And this data set is quasi-global rainfall data set, which ranges from more than 30 plus years. And by quasi, it means available for specific areas of the globe. The data can have particular uses, such as in assessing precipitation to know whether it has increased or decreased. However, it is not that helpful, or it is not for use in predictive purposes. So the dataset CHIRPS was created in collaboration with scientists at the US Geological Survey of the Sources, Observation and Sciences. And this spans from 50 degrees south to 50 degrees north and all longitudes, and starts from 1981. So here we have the resolution, 0.05 resolution. So if you are new to the concept of resolution, there is also this way of denoting resolution by degree. And this can be converted into the kilometer. So the next concept is anomalies, and this anomaly stands for the difference between the value of a quantity and its climatological mean value. So this is the difference between the original monthly value of a quantity in that given month and the monthly climatological value for that month of the year. So these anomalies have the uses in different studies. For validation of the data, we have different statistical methods. So the first one is correlation, and this correlation is for estimating of the two sets of values in how they are related by positive or by negative. So how when one changed changes the other. This is the concept. And there is next one, mean error, and this is done between the two different values, or for example here for the rain gauge and satellite data, and we calculate the difference between the two data. And the next one is root mean square error, and this is the square root of the added square difference between two sets of values. So the basic idea here is that the validation means to compare between the two different data sets, maybe within these two satellites data, or maybe within the satellite data and the field-based data. So this is the concept one. And along with CHIRPS dataset, we also have some other datasets. For example, there is this one CMAP, and this is based on the infrared and microwave satellite algorithms, and it has specific spectral resolution. So it starts from January 1979. Similarly, we have the CMORPH, started from December 2002. So it is based on the low orbiter satellite microwave observations. Similarly, we have the GPCP dataset. This is also based on the microwave satellite estimates, infrared satellite estimates, and multiple rain gauge observation datasets. And there we have the TRMM, Tropical Rainfall Measuring Mission, which are providing us from the microwave and infrared satellite precipitation estimates. So these are some things that we can explore ourselves if we are familiar with the precipitation dataset or if we want to explore more. So there can be some issues with spatial and temporal resolution. So this is to say that seasonal differences can have some can affect in the estimation of precipitation values, and some satellites can have more accurate results. So this is again to understand that the different datasets have different spatial and temporal resolution, and these resolutions can have different impacts on what we are dealing with. So next one is the temperature data. And for the temperature data, we have the moderate resolution imaging spectroradiometer, or this is popularly called MORIS. And so this instrument carries NASA's Aqua and Terra satellites. It captures images of Earth's surface in 1 to 2 day intervals in 36 spectral bands, and its spectral resolution is 1 kilometer, and the data are available from March 5, 2000 to present. And this temperature data can be used in understanding land surface changes. And while understanding the land surface changes, then here comes the land surface temperature. So this is one of the parameters to understand the land surface changes. So the anomalous concept is similar to the previous one. And then we have the validation, and what provides good estimation of temperature is somewhat researchable topic, and either MODIS daytime or MODIS nighttime. So which values is a good estimation is again researchable topic. So different research has been done. Maybe MODIS daytime or MODIS nighttime can have some accurate uses while we're doing in the research. So then there is the Ndvi data. Ndvi is the index. So the basic concept here is to understand the presence of vegetation. If the value is near to 1, or means that those areas contains the vegetation. And sometimes Ndvi can have some problems of overestimation. For example, NDVIs can represent lots of leaves, but there can be low chlorophyll, or there can be vegetation with low quantity of leaves but high chlorophyll. And in the areas of which sparse vegetation, so one using NDVI cannot be helpful for estimating the vegetation because it results the problems of overestimation. So there are other ways to understand, maybe using color composites, or maybe storing the reflectances in each band. So this is in general NDVI, however, is useful in understanding the presence of vegetation or understanding the probability of the vegetation in that particular location. So these are the 3 different data we try to go through slightly. And the basic thing to understand is that again, this training was being used for the diseases purposes, or for the study of diseases. However, we are here trying to go through the data and codes only. So to go to the codes, we have the precipitation. So for the precipitation, let's go through quickly. So these concepts have been covered in the previous videos as well, if you have followed. So here we are assigning the geometry to the variable name region. We are selecting the country name, Nepal, and from the feature collection, we are filtering the administration name, that is Nepal, and we are centering the object with the June value 6, and we are adding this as layer. So our interested data set is the troops data set, and we are filtering the data set by dot filter date starting from 1981 to 2016. And as soon as we do this, we are drawing the chart beginning from 1981 to 2016. And even for the singular, this can be done by filtering dot filter date, and this one is for the single year, starting from the first month to the 12th month of that year. And this chart making process is done by ui.chart.image.series. And as soon as we write this, we can go through other parameters inside this. And this is helpful way just to do the graphs in Orthography. This is the very easy way to do. And the area can be clipped. For example, here we are clipping the precipitation for our country bulk, and we are finding the mean. And this has been done for a single year and for the ranges of years. So two different clips here, and we are adding them as the layer. And this is the way of adding them as layer, that is done by map.addLayer. And we are assigning minimum and maximum values. We are providing some colors. The first color for the minimum value and the last one for the maximum value. And these colors are interpolated between two different minimum and maximum values. And we are providing here the name of the layer. Similarly, we have other codes here. So this is again, we are doing here for the selecting our data set. We want to have this data set based on that point. And here we are finding the means by the year. So we are finding the means of the images or for the each month. Here we are starting the months. We have the starting month from the 2012, and from that month we want to go ahead up to the 3 years. And this has been developed a function to make sure that the year goes every time when we run the function. And this is the main function here to find the mean image of every month. This has been done like this here. So every time this function is run, we get the mean of the image of every month. And finally, we draw the chart of the monthly means. So if you run this, so we are getting the chart here. So these codes again can be looked upon that document set in the earthengine guides, and we can go through this line by line. But here I just want to say that these codes can be used again. And here the basic idea is to generate the chart for the monthly image. So here we have the chart. The first one is the precipitation starting from the very first year, from 1981 to 2016. So I am just copying the date as that it was in the guide. This here can be changed. And this one here is for the single year, starting from January to the December. And here we have the means. We are selecting the dates here for the monthly images. And here we have the image collection, and this one here is the monthly means. And we get different years. You can see here the first layer is Nepal, and the other layers are precipitation. So we can explore more on the layers tab and can play with other colors as well. So this was a little about the analyzing the precipitation data. So the next one is the temperature data. So again, here we are selecting our country, Nepal. We are selecting two different bands. One is LST day 1 kilometer, and the next one is LST night 1 kilometer. We are converting them into the kelvins. Sorry, we are converting them into the degree because the original data is in kelvins. So we are multiplying by the scale value and subtracting 270.15 so that we can convert the values into the degrees Celsius. So again, we are selecting the dates. Here we are selecting for 16 years, and here for the single year, one for the nights and one for the days, for single year and for range of years. And we can clip them for our save file or for our country. We can chart the data and by ui.chart.image.series and provide different parameters. This is for the longer range of years. And this second one here is for the short range of year, that is for a single year. And this has been done for a specific region of interest that has been imported, and this one here has been imported that has been renamed as small region, and we can add them as layer. So we can run this again. So we get something like this. This one, it was for the analyzing of the temperature data. And the last one here is for analyzing the Ndvi data. And similar to the previous one, we select our region of interest, that is Nepal. We also have imported our other region of interest. So here we are selecting the MODIS Ndvi, and we filter the dates for the 2002 to 2004, and also for the single year. And we can click the Ndvi for our country and also for our small region. So we can draw the chart by ui.chart.image.series by region. This one for the single for 2002 to 2004, and the next one for a single year. Similarly, we repeat this for small region. So actually, if we're following till this, after using ui.chart.image.series by region, everything we're doing after that is just adding the parameters, what this function requires. So we provide the different parameters and it draws the chart. So we are doing this again. Here we are adding them as the layer. And this code here is again to calculate the monthly NDVIs and drawing the chart of the monthly images. So if we run this, So if you run this, we are getting the charts here. It says generating chart. And so the codes can be checked in the earthengine guides, and you can play along with these codes. So here we have the Ndvi short time series beginning from January to December 2008. And we have here NDVIs for the small area, this one for the small region, beginning from 2002 to 2008. This one for is the short time for a single year. And here we have the band mean across images. And this one here is the NDVI for a very long time in 2002 to 2008. We check the layers. Here's the NDVI. So in this video, we try to quickly go through 3 different data sets. We try to learn about the different precipitation data. We try to learn about temperature data and NDVI data. And in the codes, we basically try to look to generate the charts, and also about the generation of monthly images. So I hope this was helpful. If you have any questions regarding in any part of this video, please let me know. I'll try to solve. So if you found this helpful, thank you for watching.